Okay, so good afternoon. My name is Marcos López-Caniego. I'm an astronomer at the ESA Science Data Center in Madrid. And I'm going to tell you about this, in this presentation, about closing the loop from astronomical data exploration to scientific discovery using the Jupyterverse, which is another way of saying how we are supporting our users end-to-end since they access the data in our archives all the way into their publications. So just to give you a bit of context, at the European Space Agency, we have a collection of space missions observing the sky across the full electromagnetic spectrum. And here we have all the list from all of the missions that are currently in legacy phase and the ones that are in operations and the ones that are coming up. And some of these missions, they are not only ESA, they are done in collaboration with other space agencies like NASA or the Canadian Space Agency or Japanese Space Agency. So these are the so-called cosmic observers. We also have a bunch of missions observing the sun and the solar system. And the data that is collected by these missions goes to our data center in Madrid, where we serve it to the community. So this is just a complex diagram that we have back in Madrid. In our office is a 4-meter long posters with the technology stack for all of our archives. But just to give you an idea, we are using Jupyter in one way or another in all of these archives. Then the data repositories that we have are growing and growing. And just a few years ago, the size of the repository was a few hundred terabytes. At the moment, we are already at a few petabytes, and in just a matter of a couple of years, with a new Euclid mission and other missions coming up, we'll be reaching the 30 petabyte limit. So this is quite a lot of data that we need to make available to our users, and this data is actually being used. So many people ask, do people really use all this data? And the answer to that is absolutely. We have tens of thousands of users exploring our archives every month, many terabytes of data downloaded, and the scientific return for these projects is huge in terms of publications and new science. So but there are also many challenges. It's petabyte scale archives. So we have challenges for the scientists because they need to do science with a really large amount of data. Also reproducibility, been mentioned several times today and yesterday. But there is also a big challenge for the data centers themselves because we want to facilitate the scientific discovery and collaborative research, providing the tools and the resources for data discovery and analysis. And this is where Jupyter enters. So this is really a revolution that we've seen in the last few years, and it's been mentioned again and again how the community is using Jupyter in many ways to do science now, and we think that we want to support this. So at the beginning, so we started providing example notebooks to our users so that they could learn how to access the data in the archives and how to do simple science use cases. So the demand for this kind of notebooks kept growing and growing, and this was just the beginning. Now, the next step in this was to see what the users were doing in our archives. So the users, they come to one of our archives, they search for their objects of interest, but then before we were providing example notebooks teaching them how to, generally how to access the data. But now what we are doing is we are using the searches that they are doing, and in real time we are creating notebooks that the users can download and open in Jupyter Lab in their computers. So this is something that we've been doing for some of our archives, and this from the feedback that we've been receiving, this has been well received by the community. Then the next step here is, okay, so we have the users, they come to our archives, they want to discover the data, and then they want to do science with it. So before I was showing how we are creating these notebooks in real time, but because of these large data sets that keep growing and growing, eventually the users will not be able to download this data. So even if they download a notebook that will mimic the same query that they are doing in the archive, they will not be able to download the data. So this is why we are now making the connection with our science platform. So we have a science platform called ESA Datalabs, and in this platform we are giving access not only to the software needed to analyze the data, but also to the data itself for many of our missions. So this video, what it's showing is how the users, they can, after they make some queries in the archive, how they can execute these notebooks directly on our platform. For this, they need to be logged in, and we provide some invitation codes in our archives for people to actually get access to the platform. That is not it's available by invitation, let's say, but we have quite a large number of users now. So then, so what is showing here is just to give you a feeling of how this platform looks like. So it's based on Jupyter Lab, but we also have some other standalone applications that can be accessed there. And a typical user will come here, they will decide which software image or they want to use, and then they want to identify the data that they want to use for their analysis. So in order to make this connection between the archive and the science platform, we need to provide, at the moment, you need to provide an ID, the ID of the Kubernetes pod that is running behind scenes to link these two worlds, let's say, the archive and the platform. If you have already your instance of a Docker image already running in the platform, it would be as easy as just getting the ID and paste it into the archive, and then you will get this thing up and running in just a matter of seconds. And if you are a first-time user to the platform, you just get register, and then you log in. And then, yeah, so this is just this is an example of how we are making this connection between the archive and the platform. And then here in this cell, what is showing is how the same queries that the users were doing in the archive interface, now they can do them directly on the notebook. So now once they have the notebook running on the platform, they can tweak their queries, access the metadata, and most important, access the data itself. So even though we are providing the means to download the data, the important thing here is that we are also providing the location of all these files in the platform, so that they don't really need to download anything. And this is maybe this is an example for Hubble. This may be not super important for Hubble, but for other missions like Euclid, where there will be something like 25 petabytes of data, you definitely need something running in the platform to do your science. Then on top of these archives, we have another tool that is called ESASky, that is a kind of a visualization layer that sees the data from all the archives, and that gives users, our astronomers and casual astronomers as well, a view of what the data that is available, both in terms of observations, catalogs, etc. So here we wanted to go one step further, and then we developed a widget for Jupyter Lab that is called ESASky, and that can be installed with pip install. And then what this widget does is that allows you to operate the application directly from the notebook. So you get your notebook, you instantiate an instance of ESASky that you can access directly in the web browser in sky.esa.int. But if you are working in the notebook, you just get your instance of ESASky up and running, and then you can just operate the application from the notebook. You can just change your coordinates, go to a different region of the sky. You can zoom in, zoom out. You can change your background images. You can change that they are available at all wavelengths for all these space missions and ground-based observatories that have been provided this data. So it can be very powerful tool to discover the data that is available in a given region of the sky for any of the missions or ground-based observatories that for which we have access from our platform. So this is so we think that this is very powerful, that will be more used in the future. And yeah, so the demo continues, but let's go to the next thing. So okay, so we have, as I was saying, we have ESASky, that is this visualization layer on top of the astronomy archives, and then we want to connect ESASky also with our science platform. Before we were connecting the individual archives with the platform. Now we have this top level layer for visualization, and we also want to make the connection with the platform. And in this case, the example is with the Euclid mission. This is a cosmology mission from ESA that is observing 1/3 of the sky. And in this case, we have a big instance of ESASky embedded in the archive. And then again here, you can like navigate the sky, go to your favorite region, play a bit with the science mode or the explorer mode, because ESASky is meant both for scientific usage, but also for like all-purpose exploration of like pretty pictures. So here I'm just like selecting some data sets from Hubble, from Spitzer telescope, and from from HST, and then overlaying some catalog, filtering a bit by magnitude this catalog, and just with a click of a button you get a feeling of what is really the data that is available for this for all these missions, and then you just get to see it here. And then the important thing here is that once you make the connection between ESASky and the science platform, as you will see in a moment, it's not only you will get access to the metadata from all these data sets, but you will get access to the actual data. And again, for the case of Euclid, is particularly relevant because it will be impossible to download all of this data. So this is somewhat similar to what I was showing before. Now, the next revolution that we are experimenting now is with chatbots and agents. We have a chatbot that I'm going to just briefly show in a couple of minutes. This chatbot doesn't have anything to do with Jupyter, but still is something that is a very nice chatbot. It's somewhat old technology. We did this already 5 years ago, but it's quite actual in the sense that nobody else has anything like this. So you can still command the application from the chatbot. You can type, but you can also talk to it, and then it will just give you some options, and then you can just navigate this. You can do simple questions, and it will just show pretty pictures, but then you can go into the actual datasets, and you can select datasets by wavelength, you can select observations or catalogs or spectra from all these space missions and ground-based observatories, which is great. So I encourage you to go to ESASky and play a bit with it. But what we really want to do now is to work with agent systems. And in this case, what we are exploring is how to combine all these things that have been mentioned in this conference to support our users, to support the astronomers doing the science. And the rationale here is that the missions are getting, these projects are getting more and more complicated. They are creating tons of documentation, hundreds of different types of products, and we want to teach users how to access this documentation, how to access the data, but we want to let them do it with natural language. So what we are proposing is to have a chatbot. You go, you talk to the thing, and then with your own words you explain the type of products that you are interested in, and then using the documentation from the project, we want to extract the actual keyword that connects what the user is requesting with the data model and our databases. And then this is done in this first step, where we are using LLMs and RAG technology to enhance this part of this workflow. Then once we've made the connection between what the user is explaining or is asking and the actual products in our archives, then we have this second step where we want to create some code. This ADQL is Astronomy Data Query Language, which is just a flavor of SQL, but with a pinch of astronomy in it that we are using in our archives. And so we want to generate a code that can be executed against our archive. And then we need to have an agent also to review this code and then eventually provide this example code to the users. And then in the third step, we have again the Jupyter floating around. So because we are taking this code, we are putting it into a notebook, and then this notebook again needs to be reviewed and then archived for later download, but it can also be executed in our platform. So this is something that we've been thinking about in the last few months. And the perfect example is again this Euclid mission. It's a new mission. It's now generating lots of data. It will produce between 25 to 30 petabytes of data, depending on where you are in the mission. Many products, very challenging to keep scientists up to date of what is available and what is not, about documentation and examples. So we've been playing with this agent system. This is just a proof of concept. This is just a toy, but it did. So we managed to have these multiple agents that I was describing before, the ones that doing the RAG pipeline to enhance an LLM with the existing documentation for the project, and then another task to create the notebook and another task to execute it. And this is just like showing a bit the bits of the code, how we got the crew running and all the various steps, how they were executed, and at the very end a notebook is created and it will be shown how it is accessed. And so this is a bit where we are now, trying to convince people in our teams that this is something worth exploring, and so far the response has been very positive. But one thing is to build a small proof of concept, another thing is to put such a system in production in our archives. So it may take time until something like this is available, but still this doesn't prevent us from learning what's out there and all the things that have been presented this morning, and try to incorporate some of that into what we are doing. So just to finish, so Jupyter is widely adopted by the community. This is a fact. And what we are showing here is how these Jupyter-based solutions are really enabling the data discovery and analysis from our archival data. So we are attending these meetings. We want to share what we are doing, but we also want to learn what others are doing and how to incorporate all of that into our archives. And we are very happy to collaborate with you guys. So if you are interested in any of these topics, I'm just showing here some, like collaborative research, these agents in Jupyter Lab, live coding copilots, or GIS, just come and talk to me. And thank you particularly to the Jupyter team for creating this Jupyterverse and for sharing with the community. And then I will leave some pretty pictures while I take your questions if you have any. Thank you.